So suppose there is a question. The question is, what steps do you take to print only the tail number of each flight for the flights that departed too late, where the departure delay is more than 500, and that too with sorted by total taxing time. So I am repeating it again. So what it takes? So it requires only one column, only the tail number column of each flight. But how? For only those flight where the departure delay was more than 500. I think we later took it as 240. Yeah, let's take it departure delay more than 240. And then before presenting the data, it should be sorted by total taxing time. Now, having understood all those concepts, we have to really understand how to approach this problem. So last part is we have to use a select function where I can get only one column of tail number. But before that, we have to take only those rows where the departure delay is more than 240. That is nothing but a filter function. But we have to use a arrange function as well, because we have to sort it, either ascending or descending, we have to sort it. So now let's take approach that problem. So only the tail number of each flight. How do we get that? So we have to use select function, pass each flight, and then which column we want to access? Tail number. So as you can see, yeah, so it reached the ultimate output. But if you can see, so it would give you only one column. Now take the second statement, only the tail number of each flight for flights that departed too late. Now if I want to access only those rows where the departure delay was more than 240, we can do that pretty easily. So using filter function we can create this thing, which is pretty obvious. But yeah, so as you can see, yeah, so departure delay is 240. So but suppose on top of that we want to only extract the tail number, the same code we are using, that we want only one column which is tail number, but for how many rows? Only for those rows where the departure delay is more than 240. So what we can do, we can quickly understand the how many rows we have, we can quickly understand by using n row. So if we pass that, it's actually 389. We have 389 rows, but 389 rows and all those column, 21 column, but we want only one column which is tail number. That's why we are using select. But let's talk about the third statement, which is about sorted by total taxing time. So how we can do that total taxing time? So obviously we have to create a new variable called taxing time, which is nothing but taxi in plus taxi out. So we have to use mutate. So suppose we are creating a new data frame called each flight taxing, and there we are creating a new column called taxing time using mutate function. And once this is done, then you can arrange. So if you see this each flight taxing, it would be having 22 variable instead of 21, because a new variable has been created, and that with that new variable you have to arrange, which is the taxing time. So now we are using the fourth verb, which is arrange, and it would be arrange. So if you see this, it is having the taxing time column, and that too with sorted. Yeah, if you see taxing time, that too with sorted, like 5, 6, 7, that is how it's changing. But we have to also incorporate the first two statement. So how to do that? So the answer is, first we have to take a filter where we are reducing the number of rows with departure delay more than 240. Then we have to mutate, create a new column which is taxing time. Then we have to arrange it, and then finally we have to select that we don't want all the columns, rather we want only tail number. Now that is what we will try to do. So first we are creating the, using filter, we are creating first a new data frame called H-flight filtered, and if you see, the row is 389 and column is still 21. So earlier we had 17,000 rows in H-flight, but after using this filter we have extracted only 389 rows. Now what is the second step? Now we have to create this new variable called taxing time, and we are giving the new data frame name as H-flight after filtered and muted. Yes, and if you see how many rows and columns, so now row are same, only one column has increased, that is taxing time. But now we want to arrange it by taxing time, and we want to name it after filtered, mutate and arrange. That is how I have given the name filtered, mutate and arrange. And if you create that and see the number of row and column, there is no change. Why? Because the arrange function doesn't add any rows or doesn't filter any rows or doesn't add any column or filter any column. So it simply arrange any column, arrange all those rows based on some column. Now the last part, so now at least we can understand, here we have done the filtration, then the mutate and then the arrangement. Only thing is remaining, we have to select only one column which is tail number. So we are passing this data frame which is ultimately filtered, muted and arranged, and then we are passing that data frame and we are saying we want only tail number. And if you try to see what is the number of row and column, you would see row is still same, but column now has decreased to only 1 because we wanted only one column. So as you can see, the row number is same 389, but there is only one column which is 1. So that is what I wanted to discuss in recap, where you can understand all the verbs are being used. And then now let's discuss about the pipe operator. Now how a pipe operator works. So if you have just seen the example we discussed, so lot of time we have to use these verbs, select, filter, mutate and summarize. And if you want to do it all of them alongside, if you want to use all of them to solve a single problem, then you have to use this kind of structure, that first you are doing select, then on top of that you are doing filter, then you are doing mutate and then ultimately summarize. Okay, but instead of these complex thing, you could have done simply like this. So this is the pipe operator we are using. So we are saying on top of H-flight data, first apply select, which is this, then apply filter, which is this, then mutate, then summarize. So if you use this pipe operator, your code looks nice and it gives you much more flexibility, and there is no chance of error as well, because this kind of complex structure is very difficult to understand and very difficult to comprehend as well. So that's why let's do another example here using that chaining function. So we would be using the same example. So just now we did that, first we are doing a filter which is departure delay 240 more than 240, then we created a new variable called taxing time, then we arrange it by that taxing time, and then ultimately we selected only one column which is tail number. As you can see, it's much more clean and easily understandable. Only thing we have used is this pipe operator on top of this data, and then step 1, step 2, step 3, step 4. That's how. So you select the whole code and press Ctrl Enter, and you would get exactly the same result. So if you remember earlier here when we saw the result, that was having 389 rows and only one column. Here also we would get the same result. Let me show you. Yeah, so as you can see, after this we are getting only one column, which is tail number, but with the same number of rows, which is 389. So using these pipe operator, we can do wonders. Like we can use all those different verbs of dplyr package, and we can solve complex business problem. So there are a couple of business problem which I don't want to discuss all of them, but I will be sharing this R file, so that you can actually go through all those example and do it on your own.